Let's take a look and see how our geometric sequences relate to our exponential functions. Some refresh of vocabulary, a reminder that the input is what goes into a function. It is called the independent variable and is typically defined as the variable x. Our output is what we get out of the function. It is called the dependent variable and is often represented by y. And then we kind of talked about function notation and how y becomes f of x, not f times x. You can call it f of x or f at x. And we can use different variables, but it's important to be able to look at an equation and determine what is the input and what is the output. So let's look at a couple examples. So for number 1, we have f of x equals 2x minus 9. So in the function, we are putting x, and out of the function, we are getting f of x. On number 2, we are putting w into the function, and we are getting h out. On number 3, our input is n, and we are getting out a sub n. And number 4, our input is k, and we are getting out a sub k. Some reminders about what we discussed in Unit 5a is an exponential function can be written in the form y equals a times b to the x. Remember that y is our output, but is often going to be used with function notation, so f of x, j of t, whatever letters they want to use. A is your y-intercept. That's your initial value when x equals 0. That's really, really important. It's not the first, it's the initial, which is when x equals 0. B is your base or your multiplier, and x is your input. When we discuss the geometric sequence, I'm specifically going to be looking at the explicit or closed rule. We wrote it in the form a sub n equals a sub 1 times r to the n minus 1. So a sub n is the output, a sub 1 is the first term, r is your common ratio or your multiplier, it's the same thing as the base, and n is the input, but it's to the n minus 1. So we're going to take these explicit rules and put them in function notation. So I'm just going to use f of x, but again, you could use whatever you want. So instead of writing it as a sequence, a sub n, I'm going to change it to f of x. Now, what's really important to know is that in the current form, 4 is the first term. Okay, so 4 is our first term. That's really important to know that that's the first term. And 2 is your common ratio, which is the same thing as your base. So to write it in the exponential function form, we're trying to get it in this form right here. So we need to know our initial value or our 0 term, and we need to know the base. We know the base is 2 because the common ratio is 2, and base and common ratio are both the multiplier. So we already know b is 2. What we don't know is a. We have the first term. We need to work backwards and find when x is 0. So if I just do kind of like a little table for you guys, we know the first term is 4, and we know we're multiplying by 2. So to work backwards, we're going to have to divide by 2. And 4 divided by 2 is 2. So our first term is going to be, our initial value, our a, is going to be 2. So our function becomes f of x equals 2 times 2 to the x. In number 6, we know the first term is 36. And we know that the common ratio is 3. So we know that we're starting with 136. And we know as we go forwards that we're multiplying by 3. So to find that initial value, we're going to have to divide by 3, and 36 divided by 3 is 12. So when we write our function, the initial value is 12. The base is 3 because it's the same thing as the common ratio, and then it's to the x. All right, let's do it one more time. So this time, what do we know? We know that the first term is 1.2, and we know our common ratio is 6. So we know we're multiplying by 6. So to work backwards and find the initial value, we're going to divide by 6. And 1.2 divided by 6 is 0.2, or 0.2. So our function f of x equals 0.2, and then the base is the same thing as the common ratio, so it's times 6 to the x. And again, like, you didn't have to use f of x. You could do, h of t or p of k. You could use whatever variables you want, but just make sure that whatever you decide to be the input, that it is in your parentheses, but it's also your exponent. All right, so now we're looking at a sequence. It's 24, 72, 216, and 648. We're going to write the closed rule using a sub n. So we're doing our a sub n equals the first term, which is 24, times the common ratio, and then to the n minus 1. Now, if you can't look at that sequence and identify the common ratio, then remember to find the common ratio. Take any term, I'm going to use 72, and divide by the previous term. So that would be 72 over 24, which would equal 3. So the common ratio is 3. So that would be using your function notation. I'm sorry, your sequence rule, using that explicit or closed rule. For the function notation, that's where I want you to have f of x. The difference is that when you're using function notation, it starts with the initial value, which is your 0 term. So we know the first term is 24, and we know that moving forward, we multiply by 3, so we're going to have to divide by 3, which is going to give us 8. So our initial value is 8. Our base is the same thing as the common ratio, so it's 3, and then it's just to the x, not minus 1. So the closed or explicit rule, your exponent is n minus 1 or x minus 1, whatever letters you're using, and then the function notation is just x or whatever variable you're using. Okay, this one we're looking at a table. It says the table below represents the population of a small town X years from 2011. So very important that you see that this starts in 2011, but our table starts in 2012. We are going to need to find the initial population. So that's one of the things that we're going to have to do in just a minute. So I'm just going to go ahead and add 2011 to the table. I'm sorry, my pen is not working very well. It's quite messy. I don't know why it's looking the way it is. So write the model as a sequence. So if we want a sequence, we are going to do a sub n. We need to know the first term. We have the first term because 2012 is 1 after 2011. And the second term would be 2013, and the third term would be 2014. So we have the first term is 14,400. We also need to know the common ratio. When I look at those numbers, a common ratio does not jump out at me. So to find it, I'm going to take the 11,520 and divide by 14,400. If I do that, the common ratio will be 0.8 or 0.8, however you like to write it. And then when it's a sequence, make sure n minus 1 is your exponent. Now, as a function, we need to know the initial value or the zero term. So we are going to need to work backwards. So we're going to take that 14,400 and divide by 0.8. And when we do that, we should get 18,000. Base is still 0.8, and then our exponent is just going to be t. I'm using t because that's what it told me the input was. What percentage is the town's population declining? This was a big issue on the test. To find the percentage, you look at the base. The base is not the percent. You are going to take 0.8, subtract 1, which will give you negative 0.2. Take that answer and multiply by 100. So it is declining at 20%. That's why that negative is there, but you don't need to include your negative on your answer. And then write a sentence to describe the meaning of P of 11 is approximately 1,546. I'm not going to write it since my pen is not working quite well, but I will describe and give you a sentence, and sometimes you can take 2 sentences if you'd like. So first of all, let's kind of dissect. The 11 is talking about the years since 2011. So if we start in 2011 and 11 years pass, we're in 2022. The 1,546 is the approximate population. So your sentence should say something along these lines. In 2022, the population was about 1,546 people. All right. Levi started collecting mini ducks so that he could hide them around his house. Initially, he had 15 ducks. Each month, he plans to double the number of ducks that he has. So that word initially is very, very important. That means when he started, 0 months, he had 15 ducks. And after 1 month, he's going to double that. So that's 30. After 2 months, he's going to double that, which is 60, and so on for every month. So on A, we're writing our function. In order to write our function, we need to know the initial value, which is 15, and the common ratio, which is the same thing as the base, which is 2 because he's doubling, and then we're going to raise it to the m. To write it in our sequence form, our explicit or closed rule, we need to know the first term, which is 30. That's how many ducks after 1 month. Our common ratio is the same thing as our base, and then it will be to the n minus 1. So when you start with the first term, in your exponent it has to be n minus 1. If you're starting with your initial value, then you're just going to be your variable x or m or whatever it is. For our last problem, we are given the geometric sequence, and we are representing, we know it represents the number of students who are enrolled in virtual Spanish since 2017. So our common ratio is in our formula. That's what we're multiplying by. That's our multiplier or our base. So what does it mean in the context? Again, because my pen is not working well, I'm just going to describe it. So our common ratio is 2, and what that means is that the number of students who are enrolled in virtual Spanish is doubling every year. How many students will be enrolled in 2017? So be really careful, because since they gave you the geometric sequence, and sometimes this is where like drawing a table is really nice, that 40 is the first term. Right? And then we know second year it doubles, third year it doubles, and so on. To find the number of students who enrolled in 2007, we need to work backwards. So we're going to need to take our 40 and cut it in half, which would be 20 students. And then write a sentence to describe the meaning of a sub 6 equals 1,200 1,280. So your subscript, your 6, is representing your years since 2017. So if you start in 2017 and you add 6 years to that, that's 2023. And then the 1,280 is representing the number of students who are enrolled in that virtual Spanish class. So your sentence would be something along these lines. In 2023, there were 1,280 students enrolled in an online Spanish class.